Hello students, welcome to Learn It. We discussed about when zinc rod it is in contact with dilute solution of its own ion, that is Zn+2, then there will be oxidation, and when the same zinc rod it is in contact with concentrated solution of Zn+2 ions, then there will be reduction, and the process of oxidation and reduction continues until the concentration of the electrolyte becomes equal to equilibrium concentration. So now the question comes, what if the concentration of the solution becomes 1 molar and we take different electrodes like zinc, lithium, copper, silver and lead? At this time, what will happen? So, called as electrodes. And when we maintain the temperature of the surrounding 298 Kelvin and the pressure at 1 atmosphere, so this condition is called as normal temperature and pressure. When we maintain it, then all these are called as standard electrodes because we have established a standard condition. Hence, at this condition, the zinc will undergo oxidation to become anode. The same way, the lithium will also become an anode, but opposite way. The copper plus 2 ions start to deposit on the copper and this copper will become cathode. Same way, the silver will also become a cathode and lead will also become a cathode. This is because the nature of the electrode material. So next question comes, what if we take the gaseous material like chlorine and hydrogen? So these two are also maintained at normal temperature and pressure. So here the chlorine gas is filled in this inverted tube at 1 atmospheric pressure. Same way, hydrogen is also filled in inverted tube at 1 atmospheric pressure. And both the solutions are containing 1 MHCl. But here we are considering the Cl minus, here we are considering the H plus. Here we can see the reaction can only takes place between the junction of this gas and this liquid. So that's why, so as to curb this difficulty, we introduce a system which is made up of platinum plate which is connected to platinum wire. At this time, the reaction takes place on this platinum plate. Then what will happen with the chlorine? Whether it will be cathode or anode, that we will see. We know that chlorine is an electronegative atom or electronegative element. So that's why chlorine will undergo reduction. So that's why chlorine acts as a cathode. The interesting phenomenon happens with respect to hydrogen electrode. There are two possibilities. First one, the hydrogen can act as an anode. The representation is like this. Or it can act as a cathode. But at this normal temperature and pressure or standard conditions, the hydrogen acts neither as anode nor as cathode. And we know that it can easily undergo oxidation, that is hydrogen can easily undergo oxidation into H plus ion, or H plus ions can become hydrogen. We use this standard hydrogen electrode as a reference electrode. reference electrode means we use standard hydrogen electrode for measuring the potential other electrodes. So let us see with an example. So we know that both zinc and lithium electrodes act as anode. But the question comes, in between zinc and lithium, which electrode has more tendency to donate the electron, which is called as oxidation potential? And second one is how to measure it. The answer is, we take the zinc electrode and connect it with the standard hydrogen electrode. Here both the electrode materials are connected through wire. In between them voltmeter is placed, and both the solutions are connected by salt bridge. So this constitutes a cell. So here the function of salt bridge is it completes the circuit and it maintains the electrical neutrality. So we will see the working of cell. So here we know that zinc will undergo oxidation at NTP, but hydrogen, it acts as anode also cathode. But in this case, when zinc is acting as an anode and it is producing electrons, these electrons travel through this wire and enter into the platinum wire and sit on the platinum plate. Then the H plus ions present in this acid or this electrolyte gains those electrons and convert into hydrogen gas. So zinc will undergo oxidation, hydrogen will undergo reduction. So zinc acts as an anode, hydrogen acts as a cathode. And the voltmeter here shows how much zinc is having more oxidation potential. So this voltmeter shows the reading, that is 0.76 volt. It means the zinc is having oxidation potential 0.76 volt than the hydrogen. So this cell can be represented as zinc, which is solid. It is in contact with Zn+2 ions, which is having the concentration 1 molar, which is connected by salt bridge. This double bar indicates the salt bridge, which is in contact with H plus ions, which are having the concentration 1 molar, which is in contact with hydrogen gas, which is connected to platinum. Here the left hand side indicates the anode, which is connected to, this is anode, which is connected to cathode through salt bridge. So if we take this cell, so I have already told this is a cell. If we take the cell, which is made up of anode zinc and cathode hydrogen, which are connected by salt bridge, it will measure the voltage 0.76 volt. But in reality it doesn't exist. It is a hypothetical cell. So the anodic reaction is oxidation, that is zinc will convert into Zn+2 ion and gives the 2 electrons. So the concentration of this anodic solution increases. In the cathode, when these 2 electrons come, they will sit here. These 2 H plus ions in the acid takes those 2 electrons and they will convert into 1 molecule of hydrogen. So there will be evolution of hydrogen. So in the anode side, the zinc will be dissolved. In the cathode side, the hydrogen gas is liberated. So this is the cell reaction. So instead of this, if we take the zinc rod and we put this zinc rod in the acid, this is H plus means acid, then this cell constitutes, which is having the potential 0.76 volt. So that time the zinc will undergo oxidation, means zinc dissolves in the acid and simultaneously hydrogen gas is liberated. So this is the reaction. In the same way, if we connect lithium electrode with hydrogen electrode, here the voltmeter shows the reading of 3.05, which is higher than the zinc, because we already know that lithium is the most electropositive element. So lithium wants to undergo oxidation. That's why lithium has more oxidation potential, that is 3.05 volt, than the zinc, which is having 0.74 volt. Remember, this 3.05 volt and 0.76 volt are potentials, because these two generate the electrons and give the electrons to hydrogen electrode. So cell representation is same like zinc. The lithium, which is solid, in contact with lithium cation, which is having the concentration 1 molar, which is connected to salt bridge, which is connected to hydrogen ion or acid, whose concentration is 1 molar. It is connected to hydrogen gas, which is connected to platinum wire. So here lithium acts as an anode, which is connected to cathode through salt bridge. So if we take the hypothetical cell made up of lithium and hydrogen gas, which are connected by hydrogen, then the voltmeter reading shows 3.05 volt. The anodic reaction involves the lithium undergoes oxidation to form lithium plus ion and 1 electron. And the cathodic reaction is when two hydrogen ions react with, or when they gain 2 electrons, there will be formation of hydrogen gas. The overall reaction, which is balanced, it means that atoms should convert into lithium ions, which will liberate 2 electrons, and they travel through this wire and sit on this platinum plate. After that, the 2 H plus ions, they gain those 2 electrons and become hydrogen gas. Or when we put lithium metal in an acid, there will be formation of lithium cations. It means the lithium dissolves in the acid. Simultaneously, there will be evolution of hydrogen gas.